Welcome to normal distributions. So this is a very specific shape to a distribution. It's essentially the symmetric with a central peak, but a special case of symmetric with a central peak. I'm going to stop drawing the histograms and just focus on the outlining curve in the background. So the general shape, this is sometimes referred to as a bell curve. It can be as narrow or as wide as necessary, but it has this sort of hill shape to it. It is a special case of symmetric with a central peak. Technically, this curve fits a very specific formula. You're not responsible for that. I will just tell you something is normal. So key things, this is symmetric. It's basically a hill. We often refer to this as a bell curve. The center is the mean. It's literally smack in the center. So it's right at the middle of the peak. And just like with the probability distributions we saw before, this is now more theoretical, and we will use mu as our mean. So the mean now will be denoted with the Greek letter mu. It's pronounced like a cat, mew. And so, as I said, that is right in the middle of the peak. This is our mean. For spread, it's symmetric. We can use standard deviation. We will again use the Greek letter sigma. It looks more or less like a 6 that's been rotated. And the standard deviation we can actually somewhat tell from the curve. So if we look at our curve and we look for where it appears to switch from being sort of a cat to being a scoop, so that's referred to as a point of inflection. That's maybe somewhere in here. It switches from being a cat to a scoop. Then if we go from the mean out to that point, that distance is our standard deviation. So this is the general center, shape, center, and spread for a normal distribution.